Hello world, Micah here. Gonna talk to you guys today about a blog post that I wrote. 3 basic programming concepts that you need to know. I'll show a link in the description for that. Basically, I'm just gonna talk about 3 concepts I think are super important, and I'll show some examples because I learn from examples. I don't know about you guys. First, I want to talk real quick about what programming even is. So I'll go deeper into detail in the blog post, but just an overview is programming is how humans communicate with computers and how they get computers to do things. So when we program, we are trying to tell the computer how to manipulate some information. So the computer doesn't understand without some sort of conversion, the computer won't understand what we type in. So we have to have another program convert what we type in, the programming language, into what the computer understands, which is called machine code, or maybe you've heard of binary. So the computer understands that, but we understand the programming language. So we had to write a program to convert it. Hopefully that makes sense. So what we type in, those are instructions. So the compiler and the interpreter, those are the programs that convert what we type in. They take in our instructions and translate that into some machine code. Okay, so those instructions, what they're doing are the 3 main concepts. So we're storing information, we're manipulating information, and then we are structuring information in a way that makes it reusable or makes it easier to work with or easier for the computer to handle. Makes it easier to find. Just basically, when we structure information, we're just doing it for convenience and usability. Alright, so I'll show some examples of these concepts real quick. This is the blog post. Let's see here. Alright, so this is a pretty cool little website. Lets you type in some code. They support a lot of languages. This is the second time I've tried to record this video. The first time was terrible. Alright, so storing information. Let's do that concept real quick. So you need to know that programming languages have some syntax, some special things that you have to do in order for the translator, the interpreter, to understand what's happening. So this is the first line, it's the first example of how to store some information. So let's say that I'm storing my name. So this is a keyword, that's why it's highlighted blue. This is the keyword telling the programming, the interpreter, that I'm about to give it a variable. So my variable is called name, and it gets assigned to this value, Micah. Okay? So you could also have another variable called age, if I wanted to store my age. You'll notice I have to put this semicolon at the end. You might be wondering, like, what is that even for? So if you don't put that, it's saying redefinition of, this is because the previous program that I ran had the variable name. So it says missing semicolon. So that's a part of the syntax too. So the semicolon tells it that this is the end of the line. There's no more code after this point on this line. Go to the next line. Okay. See how like granular you have to get with this? You have to get pretty granular. You've got to be very specific. Not all programming languages require the same syntax. Every programming language has a pretty different syntax, but they have some commonalities, some similarities. Okay, so this is an example of storing some information. So for manipulating information, let's say that I wanted to get my age from 1 to my actual age, which is 23. So we have to use the storing information concept in order to change the value of my age. So age equals, so we're going to store into age some new value. So I want to increase or increment my current age. So I'm going to tell it to assign it to the value of my age plus the missing amount, which is 22. So now my age should be 23. You see this website has a run option on it. So 23, it went ahead and output the last variable that I defined. Does this make sense? You can manipulate all kinds of information. Information is everywhere. So you could have the names of all your friends, that's information. You could have how much money you spend every week, that's information. All the stores that you go and shop at, that's information. All the books in the library and what's inside of them, that's all information. Programs are you storing and manipulating some information, okay? The other concept that I have is structuring your information. When I'm talking about structuring your information, I'm talking about making it in a way that is convenient for you to use, and it normally when you have your information structured correctly, your code reads and works very, very nicely. Okay, so you see right now I have name and age. Let's say that I wanted to make 100 entries of this type of information. Like I want to store 100 different people's name and age. You think I'm going to make a variable for each person? Name 1 equals Bobby. Name 2 equals Sam. Name 3 equals Blake. Do you see how this would get really annoying is if this was the way that you had to do it? You have to make a new variable for each name. What if you wanted to store their age with that too? You'd have to do age, and then if you didn't name your variables in a way that indicated that they were related, you would never know that this is the same person's age. What if Sam is 13? I have to do age to 13. See, I'm storing 13 to age 2. Okay, so do you see how this could get really cumbersome? If you're storing a lot of different types of information about one thing, then you need to structure your information in a way to where it's easy to work with for you and for the computer. Generally, it's more for human use because a lot of times the computer can optimize what you write, and it can figure out how to interpret your code in a way that is easy for it to run. But for human readability purposes, we need to structure our information, and a lot of times structure can actually lead to some very good, some very efficient programs from the computer side as well. For instance, let's say that we had all those variables defined and we want to define the age of Bobby. We wouldn't have been able to do that unless we would have manually went through the variables ourselves. We wouldn't have been able to get the program to automatically tell us the age of any person that we asked for, because the computer did not have the relationship between those two things. So there's a couple ways that we can structure information. One of those ways is called a map. So basically what a map would look like is we would say their people. This is one way of doing it. I wonder, does it let me use let? Let's see if it lets me use it. Haha, lets me. Okay, so yeah, it does support. So this is an example of how programming languages evolve So let used to be this, or var used to be the standard way of defining variables, but now let is the way that people define variables now in the newer version of the language. And if you are interested or confused of why that is, you should look up ES 2015 or JavaScript. I'll put a link in the description for those that are curious about newer versions of JavaScript. So I could do people like that. So these curly braces are telling JavaScript that this is an object. If I didn't put this, then it wouldn't know what kind of information people was, so it would just be undefined. So if I run this now, it's still saying 23. So I wonder, how is it saying 23 now? Is it just because I didn't do people like this? Okay, so it just prints out the last line of a variable. That's where a variable is. Okay, that's weird. So if I wanted to structure it to where I could get the age of any person, I could do like this. This is called a map. So whenever I'm defining my information, I can define it in this way. So what I'm doing is I am mapping the key Micah to the value 23. So essentially what this is, people is like a dictionary where it has entries in it, and each entry in our dictionaries that we use with English, we have a mapping of a word to its definition. So this is a dictionary where a word maps to a number, or a name maps to an age, if that makes sense. So this is just a way you could structure information to where it would make it very easy for you to get the ages out of the program. Okay? Okay. So there's these concepts like maps, and there's another concept. Let's say you just wanted to store a list of all your friends' names. Okay, so we could use what's called a array or a list to store information in a structured way. So let's say that I wanted to put David and Luke in here. All right. Do you guys see anything wrong with this? I just defined this variable here, but I didn't tell the programming language that I was going to. So it might be kind of confused if I don't tell it to. Okay, so let's say, okay, so it's outputting 10 right now because of this line was the last one to assign something. Okay, so you might be wondering, like, what advantage does storing my friends in a list have? So if I got a new friend, I could do friends, and then I could push on a new friend. So push, basically, they're viewing this as this list has an operation that you can do on it. So that's why you want to structure your information, because you can define operations that can be run on the information. So pushing is a way of adding a new item to this list. So I should probably print out or show you what friends is. Okay, so you see it's got David and Luke in there. So if I do friends.push and then I put John in there and then run it, it's outputting 3. So it's outputting the length. It's outputting how many friends I have. So if I wanted to output my friends, I could just do this. So now you see John is in there. So that was push. So when you structure information, it lets you define operations. So operations go with the second concept of manipulating information. So if you have an operation or a method or a function, some way of taking in, it's an operation that you have told the computer how it should do it. So it's a named operation, let's say function. This is a syntax for defining a function. So we could do add 1. So when you define a function, you put the name of the function, that's what this is, add 1, and then you put some parentheses, and in the parentheses, this is the syntax of it. In the parentheses, you put what we call an argument. So an argument, we could say number here. So I'm going to add 1 to any number. So this is a way of defining a variable. You see how I have let friends up here? This is a way of defining a variable that is accessible only inside of this function. So this right here is called a block. We use a block to group some instructions together that are related. So I'm about to put some instructions in here that are related to adding 1. Hopefully that makes sense. So number plus 1. Does that make sense? I'm adding 1 to a number. Here's the syntax. Here's where syntax can get you though. If you didn't know that you have to tell the function it needs to output something, then you just wouldn't be able to do this. So you need to know that there's a keyword to tell the function that it should output something. So if you're wondering why doesn't it just automatically output it, so that's a good point. There should be a way to write it that way, and there is, but I'm not going to show you that. I'll let you find that for yourself. But if you didn't have the concept of returning and it just automatically output the lines that you put in here, what if you needed to add 3? What if you needed to add 3 and you wanted to store the number into a new number? So you want to say new number equals number. This is a terrible way to do it, but let's say you did new number plus 1. Oh wait, we need to store that to new number. Okay, so new number equals new number plus 1. New number equals new number plus 1. New number equals new number plus 1. Okay, so I'm adding 3 here. It's a terrible way to add 3, but you have to tell it what to output. So in order for us to tell it, we use return. So now I don't need to do new number plus 1. So this is called a function. The reason you write functions is to group some instructions together that you're going to need to run pretty often. So if you're writing the same block of code over and over, same instructions over and over and over, and you're copying, pasting it everywhere, don't do that. Make a function. It's better. Okay, that's all part of the structuring information concept. This is kind of like tying it all together with push. So what we're doing is we're storing a new element to an array. So in programming, we have these things called data structures, which is how information is structured, and operations that you can do on the data structure. So I'll show an example of what we're doing up here. I'm going to erase this stuff. So you see how we're storing people's age and their name? Another way of defining a data structure is to define a class. So this class is a keyword. Let's say we have a class person. So when you define a class, you open a block. That's what these curly braces are. You open a block and then you give it some way of making a new person. So most languages have these data structure concepts. Not all languages have this concept. So they do have ways of structuring information in all languages, but this concept in JavaScript, I'm showing you a class right now. So if we're making a person, we need to be able to store their name and their age, as we see up here. So we have to make something called a constructor. A constructor is a function that you run on some input, and it builds the person. It takes in all the information you need to make a person. So we're saying our person is going to have a name and it's going to have an age. So if we want to store something to the class's memory, to store it inside of the class, we need to use this. So this is a tricky thing in JavaScript, and you're going to have to research it on your own if you're trying to learn JavaScript. But the concept is we're trying to store this name from the constructor. Okay. So these, once again, these are the arguments of the constructor, and I'm storing them into the class. So this .age equals age. Okay? That's how you structure the information you would need for a person. So why would you want to do that? Let's say that you have some common stuff that you do on every single person that you meet, or every person that you describe has this operation or has something that you can do with them. This is called object-oriented programming. You want to look more into that if you're trying to get into any of the object-oriented languages like Java or JavaScript, C#. If you're trying to learn basically modern day development, you probably should be familiar with object-oriented languages, because a lot of them are object-oriented. And when I say object-oriented, I mean it has some way of describing objects or describing entities. So that's what I'm doing right now. I'm describing a person, or describing the type called person. I'm describing some way, I'm telling the computer how to represent a person. Hopefully that's pretty clear. Okay, so one thing that you can do with people is you can make them get older. This is not really good object-oriented programming to do this, but I'm going to leave it as birthday because this is an example. Alright, so what happens on your birthday? So this is just a good little programming exercise. What do you think happens? What should I be doing on birthday? Alright, you guys got it? This is making your age go up by 1, right? That's what happens when you have a birthday. So now we've got some stuff in here. Probably wondering, how do I even, what do I do with person after I make that? What do I even do with that? Alright, so there's some syntax for how to use classes, how to make a person, if you will. So I'm going to say me is a new person, and you'll notice here that I have a lowercase class name. Normally you want to do uppercase to indicate that it is a class. So a new person, and I have to give it whatever arguments I give it after the class name get passed into this constructor here. So this name is this parameter, and it gets stored into the class. Now I could have named these a name, and then I'd have to change it here. Hopefully this makes it a little bit more clear in case you're confused about the parameters, what's why are these things matching up? So this matches with that, this matches with that. Okay? So it's storing name and it's storing age. The parameter names that we pass values into are a name and a age. Okay, so I'm going to put in a name, and then I'm going to put in an age. Oh, 23. So in JavaScript, I could have passed in 23, the number. I'll show you guys what happens when you do that. So if I do me here, like I want, that's to get this thing to output it. So it shows my name is Micah and my age is 23. So classes are an example of a way to structure information. If I do me.birthday, I call that function and then I output me again. Let's run that. 23. Huh, that's weird. How come it didn't make me 24? So you may have noticed that I did not set age equal to age plus 1. I didn't increment or increase age. So now it should say that I'm 24. Okay, so hopefully you see the advantages of structuring your information this way so that you can do the common operations on them, and so you can reason about the code very easily. Like if you read this code right here, it should be pretty clear what's happening. Hopefully you agree. Let me know in the comments if you have any problems with this video, which since it's the internet, I'm sure there's a million things wrong with it. Subscribe to my YouTube channel if you are interested in more videos like this, and thanks for watching.